We haven't started content yet.
Yeah, that's okay. We did too, so I'm not even finished roll yet. Okay, so Jesus, you are here. Why did I put a question mark after Jesus?
Maybe last time.
Yeah, that's probably it.
You put one on Miguel Barbosa.
That's what it was. Miguel has, oh, right, it's Miguel Barbosa. Now they gotta put the question. Cron OUS question mark. Okay. Jesus is here. Austin. Austin. Lewis.
Present.
Benjamin.
Here.
I'm hearing somebody's desk. Who's? I'm gonna mute you, Brandon. I'm gonna mute you, Eric. Somebody's paper shuffling. Adier. Adier.
I'm here.
Thank you. Zach.
Here.
Eric Mendez. Garcia. Eric.
Here.
Is it? Do you go by Eric Garcia or Eric Mendez?
Whichever. I don't.
But anything but late for supper? Yakub, Jacob. Dylan.
There.
Matthias.
There.
Brandon.
Right here.
Angelo.
Here.
Sorry, there. Joel.
Here.
Joel, where are you? Where's Joel? Joel, just walk in? No, that's Austin. Where's Joel? Joel, what happened to you last week?
Honestly, I took my girlfriend out for anniversary.
All right. Well, you got an unexcused absence, but thank you for being honest and not lying about it. That goes a long way, I swear. Because if you had called me up and said, hey, I'm taking my girlfriend, I would have gone, yeah, that's not a good excuse.
Yeah.
Better you just did it. When you know that you're not going to get an excuse absent, just do it and just suffer the consequences, but be honest about it. Michael Silva. Jose Silva.
Here.
Jose. You know, people's faces are so much more memorable when they're not wearing masks. It's Tapia, John. All right. Okay, good. And now did Jacob Miller show up anywhere? Miguel, I got a feeling Miguel's gonna, yeah, I'm sure that's what he meant. Okay. Okay, so we did roll call. Let's get right into a safety meeting. Week 4. Wow, you realize what that means? Can anybody tell me what that means? At the end of the night, we will be a quarter of the way. What does that mean in terms of percentage?
25%.
5%. What does that mean in terms of a fraction? A quarter, 1/4, right? Or 25% of the way. That's like, it's done. So tonight, we're going to talk about, or we're going to have a safety meeting on belt sanders.
Belt Sanders.
Belt sanders. I'm gonna drop the screen. And then someone's gonna be my light person, please. And then I'll need a heavy person too. Offset my light person. Just laugh a minute today. So, you know, I know this is a measuring and calculating class. So most of our safety topics aren't going to have a heck of a lot to do with this, with the safety of measuring and calculating. There isn't a whole lot that measuring and calculating that you can attribute to safety, how to do it safely. In other words, don't stab yourself with a pencil. stuff like that. But
Can you hurt yourself with a tape measure?
you can do paper cuts too, and you can really hurt yourself with the tape measure. It's true, but this is geared for construction, measuring and calculating for construction. And so in construction, we have safety meetings because we want to do everything safe, and you're going to be obliged to do safety meetings. Topics are always good. I like all the topics. So this is belt sanders, class B. I'm not sure what a class B belt sander is, but let's find out. I'll read the introduction. A belt sander is one of 4 electric sanders available on the market today. It's typically the largest portable sander. The problem with these types of sanders is that few people know how to properly use one, and that is so true. That quote could have come from me. Using a belt sander can pose some risks to employees. Following safe work practices presented in this lesson will help ensure, oh my God, employee safety. Look at that poor bastard. That's a Makita too. All right, so John, would you read hazardous risk?
Hazards. Using a belt sander can expose employees to several risks, including the following. Fire. When working around flammable liquids, gases, or dust. Electrical shock. Using sanders on wet wood. On wet wood or working outside in a wet environment. Clothes or hair getting caught in the moving parts of the power tool. Skin and extremities getting pinched or caught in the power tool.
Okay, there's something else that happens with belt sanders that they're not talking about. And that is when the belt sander comes flying off the table, it could hit somebody. Besides bust the belt sander or damage work that's somewhere out in front of a place that a belt sander is being used. Most people don't know how to use belt sanders properly. Look,
It said class B at the top. What does that mean?
I don't know yet. I'm gonna try to find that out. I'm thinking class A is a stationary belt sander, like a wide belt sander. I'm thinking that might be class A. But the reason why I say that thing about belt sanders shooting off of tables is because if you take a belt sander from there, we've got 4 or 5 of them. Every belt sander has a trigger lock. It's a little button on the side, just like a lot of electric tools do. You pull the trigger, you lock it in, and it does this thing. It doesn't have different RPMs. It gets right up to speed, and it just has a roller, a drive roller. It rolls around and drives a belt around, right? And that belt is anywhere from 40 all the way up to 220 grit, and that's grains per inch. From super coarse to super fine, and they can take a lot of meat, and they can really damage your work if you're not careful and you don't know how to use them, if you don't know how to do long strokes. There's a whole technique to the belt sander. But what happens with a belt sander, and I've seen this happen more than once, and it's happened to me more than once, is that what will happen is when you're sanding, you're doing any amount of sanding, you peg that trigger. You lock the trigger on, and now you're just guiding the tool, which is what you should be doing rather than holding down and guiding. So trigger's locked, you're just guiding the tool, right? And then when you're done, then you hit the trigger and it undoes the lock. Now, a lot of times what will happen is when you will move along a piece of work and you will pull the plug on a belt sander, because this is the movement of a belt sander. And if you get out a little bit far, you'll pull that plug out of the socket. And I'm seeing too many times where guys and gals don't realize or don't remember that it's locked, and they go walk over and they plug that tool in, and it just starts up and shoots right off the bench. It starts up, pulls its plug, but it's got enough momentum where it just goes, wah. So I famously remember a female that worked for me. Kat was her name. She was a cabinet maker. She was a good cabinet maker. But we had this particular bit. It was expensive bit. It was like $54 a bit. This was 20 or 30 years ago. So $54 was worth like about $500 then. And there was a 3 tapered bit. It was used for these conformat screws we used to put cabinets together with. And like 2 of them had already broke, and I was getting really bummed about it. And like a 3rd one broke. What the heck? What happened? So, and Kat broke it, right? And so I had her in my office talking about it. I said, you know, what about this break? She said, I didn't break it. I said, really? Because I thought you broke it. She says, no, the belt sander broke. I was belt sanding and then it caught the drill motor, the cord caught the drill motor and it pulled it off the bench. Oh, and so it wasn't your fault. It was the belt sander's fault. Well, go get the belt sander, bring it in here, and I'll have this talk with the belt sander. Never forgot that. Neither did she. All right. Hazards, please. Wait, you just did that. Personal protective equipment. Next. PPE. Yes, please.
Personal protective equipment. Employees should wear the following personal protective equipment: safety glasses, hearing protection, dust mask if working in a dust environment.
Which is optional. Yeah, dust masks. Well, if your vet center's got a good bag on it, which it should, then you should have dust mask. So, stick with mattresses, please. Yeah, please.
Consult the operator manual to ensure that you are complying with manufacturer instructions. Inspect the belt sander and sandpaper. Replace the sandpaper if it's worn down or to come up with dust and dirt. Should you find any malfunction or broken parts, not use the belt sander and report it to your supervisor. Wear safety glasses and hearing protection. Use 2 hands when using a belt sander. Watch the placement of any power cords to ensure that the belt sander does not catch or go over them. The cords could become damaged, causing electric shock or get tangled in the power tool.
Okay, stop. Michael Silva. Do not force the sander.
No.
You talking, Mike?
Am I? I think I am.
Now you're coming. Now we hear you.
Okay. Oh, sorry. Do not wear clothes or loose clothing. Do not place the sander facing towards your body. Wear long hair up and tied back. Do not use a belt sander on any wood that is wet. It is to be used on dry wood only. Utilize any dust collection that is provided with the belt sander. When you have finished using the belt sander, check the sandpaper. Wait, I gotta move the little boxes. If the paper is not too worn down, clean the paper with an abrasive cleaning stick. And when not using the belt sander, ensure that the power button is in the off position.
And not locked. In conclusion, a belt sander does not have to be dangerous so long as the safe work practices are followed. So interestingly enough, you see that picture? That's a 4x24 Makita belt sander. You see how he's halfway, he's like almost halfway onto that flat part of the platen there. So the belt sander front roller is hanging over the edge. That is how you need to belt sand, because the belt sand roller comes up like that. If you just come to the end there, it's not going to be sanded out to the end. You need to hang your belt sander out over the end. Another thing you need to do with belt sanders, whenever you're belt sanding on the bench, you need to block it. You need to have a stop against it, because the belt sander will want to take your work and shoot your work back that way, because your belt sander goes this way and it's got, it's got a fair amount of grab on your work. And if your work is not up against the stop, your work can just go flying too. But more than anything, if you are using a belt sander, just make sure you know how to use it. And if you don't know how to use it, get some practice. It's not an easy tool to use. Well, I take that back. It is a relatively really easy tool to use. And if you don't use it properly, you can really damage it like really gouge it, take it in, get big dips in it, just do all kinds of that. In some ways, there are better sanders. Belt sanders are really good for taking a lot of meat. I love belt sanders. I've used a lot. In the shop, we have white belt sanders. That's collection of it. It's good to clean the belts. You go one way, and there's usually an arrow. There's usually an arrow on the inside. Yes, what's that?
Will a belt sander put a pattern in the wood?
Not so much a pattern, but it will So the thing about sanding, here's the thing about sanding. The thing about sanding is when you sand something, when you sand wood, what you're doing is with your roughest grit, which is typically 80, and you can go rougher than that, 60, even 40. You're using the belt sander to take off, or what you're, whatever you're using to sand with. You're using it to take material and to shape the wood with your 40, 60, 80 grits. After that, after 80, you're not. Why is that thing so badly focused?
Maybe the light.
Yeah, try the lights. Whoa, now it's really bad. It's getting better though. It's getting better. And hit one of those, turn one of them off, please. So in sanding, and I know this is way off topic, but we're talking about belt sanders. 40, 60, 80, right? Those are the very coarse grits. You could really damage wood with 40 and 60. That's for really taking meat out, trying to get a board flat, maybe take a little hump out of a board if you don't have a joint or a face joint. Really sand down a bunch of glue or something very carefully. You can use a rougher, but you're taking meat that is wood, 40, 60, 80. And usually starting with 80, because 40 and 60 are so rough. After that, all you're doing is taking the scratches out from the previous sand. So when you go to 100 from 80, you're taking out the 80 scratches. When you go to 120, you're taking out the 100 scratches. When you go to 150, taking out the 120 and 180, right? You're just taking out the scratches and making finer scratches until you get to the 220s, which is about as fine as you're going to want to get wood. I mean, you can certainly go into the 280s and 400s and 600s, and I have on a variety of projects, but most stuff 220 is as fine as you're ever going to get it. And then the last thing I want to tell you about sanding, taking the scratches out. Let the sander do the work. Let the belt sander do the work. You're there to guide the belt sander. You're not there to push down on it. You're just there to guide the belt sander. Guide it flat, guide it over the wood, so it comes about middle of the platen, and not dip it, keep it nice and flat so you're not dipping an edge and putting a groove in your board. I've seen people ruin work with belt sanders. So be careful. And they can be dangerous too. Okay, so I have been kind of lax with breaks and stuff like that. So this is what we're going to do from this moment on, and it could change at any time, but I'm telling you right now that after 50 minutes of class, we're going to have a 10-minute break, right? So 7:50, we're going to break till 8, and then at 8, we're going to go till 8:50, and then we're going home tonight. Okay, so I'm going to try to do 45 to 50 minute, because I know I was doing this in the summer for a couple of classes I had, and it was working a lot better. People were staying awake, especially this time of the evening. So you guys get a break, take a leak, whatever you got to do, and then get back, and I'll try to make things flow along. Now, this being my class, and I'm not sharing it with Jim, and I'm not like kind of trying to. Jim isn't running the show. This is just my class. I may talk about anything I feel like talking about. I'm going to tie it to this, and I'm going to keep it with this measure and calculate, but I might go off on tangents, bunches of tangents, which I have every intention of doing tonight, going off on a bunch of tangents. So we'll either get through the stuff I wanted to get through, or we won't. It won't really matter, but we're going to start out with, I'm going to show you some pictures. I want to show you some pictures of, Let's see, I got to get back to somewhere, back to the inbox. Okay, so this is my inbox, and here's some pictures. That's my dog. That's my dog and my wife. I didn't mean for that one to be in there. But so This is, remember I talked about sketching and dimensioning, and about drawing scale and stuff like that. So today, this is a sketch. It's a dimension sketch. It's not drawn to scale by any stretch of the imagination. So it's a 8.5 by 11 quarter-inch graph paper. It's the pads that I like. And I met with a guy and I made a bunch of notes about the scope of work. And in my kind of shorthand, it says kitchen remodel scope, demo existing countertops, cab, stove, microwave fan, sink, DW, reuse existing reefer, just a whole bunch of notes. And then a not to scale. Sorry, guys, I need a minute here to mark Jacob,
Yep.
right? Jacob here. Glad you made it, Jacob. So, you know, I do, because it's quarter-inch graph pad and I'm aware of the scale and all that stuff, this is relatively close to scale, but it's not to scale by any stretch. It's a sketch and it's dimension. So I measured 711, 80. I got the parameters of the kitchen and sketched out what's existing and what goes where, with a few keynotes about ceiling height and openings and stuff like that. And from this, and then similar thing here for his bathroom, you know, just a bunch of my notes about the scope, and then a sketch and dimensioned drawing of the room. It's got dimensions, and then I will turn these into something that looks like this. So can't get any smaller now. Okay.
Can we turn off the light?
Yeah, please. Oh, yeah, and let me get this projected.
We should get the next one.
Thank you. Thank you. So my Zoom guys, this will bring it up here in a second. And so that Spencer House job, it's a 113-year-old Victorian. I think it was built in 1908. It's 200 West Victoria. And I did the same thing there. Went in after meeting with the principal, the owner's daughter, actually. Went in there. Now, you guys aren't going to be able to see this on Zoom, and maybe I'll show it to you in a bit. But similar thing, right? Bathroom. A dimension sketch. Kitchen. Dimension sketch. Right? Same thing. Wait, that's too bad. I went back twice. I needed some stuff. That's the kitchen. No, that's the bathroom still. That's just a crazy sketch I did of the kitchen. So really a bunch of dimension sketches, and then I made out hand-done scopes. Don't remember where, but anyway. So after showing you that, what I want to show you now is what I turned that into. So what I turned that into is this. Turn into a plan view. There's my scale, 3/4 scale. There's the walls in scale, 3/4 of an inch equals a foot. That dotted line is the line of uppers above, base cabs below. So that A and that B, those are plan notes that show my elevations. I'm going to have an A elevation, I'm going to have a B elevation, which means my A elevation is standing about where that A is, looking at that wall. So here's my A elevation. I show the crown, I call out the crown, I show the height, what I want for the cabs, cabinet height, the style, how I show the styles and rails, the style of the cabinetry. call out existing beadboard, which actually that turned out to be a full height backsplash. And then that's what the cabinets below look like. That's the A dimension. And then the A wall, there's an alternate A version. So instead of uppers and lowers, full heights, full depth, full height. And then here's the bathroom. Wait, that's just the B dimension of the bathroom, same room. There's the B dimension, the WC, the toilets right there. I just didn't draw it. False front, pair of doors, you know, everything's dimensioned. There's a mirror above, right?
Is this what's existing or what you're proposing?
No, that's what I'm drawing. It's not what's existing. This is
Okay.
this is what I want to be done.
Got it, got it.
This is the plan. And then here's the scope of work for that. So that's the second floor bathroom remodel. And there's all the things, the 22 items that I want in the scope. And unfortunately, 22 didn't happen the way it should have. I really dropped the ball. And the reason why I dropped the ball is because as UT Construction, my old company, got the job. And so I figured they didn't need to pay me $125 an hour to supervise when they were going to have some kind of job supervision, and they were perfectly capable. They were a small job, they could do the job supervision. And I didn't stay on top of it, and I should have. Consequently, some stuff happened that shouldn't happen. Like, there's a garbage disposal, but there's no outlet for the garbage disposal. Yeah, there's no switch either. So that had to be dealt with. There's also, if you notice the drawing, that's the scope. If you notice the drawing, you can see, I don't know if you can notice, but the stiles, the vertical members of a frame and panel door are stiles. The horizontal members of a frame and panel, door, window, anything are rails. So stiles are vertical, rails are horizontal. The top rail is the same width as the stiles, but the bottom rail is wider. And I call it out somewhere, but the bottom rail is like 3 1/4, and the top rail and the stiles are 2 1/2. So when I got there, the knobs were bored in place, and 4 of the doors were narrow bottom rail on the bottom, wide top rail on the top. So they had just flipped the doors around because they're bored the same. They're bored the same from top to bottom. So they could be just flipped around, snapped on upside down, which they were. So they had to fill the holes, repaint them, and rebore them. And then here's the drawing for the kitchen. There's a down view of the kitchen where the reefer goes. The dotted line is the upper cabinets above, dotted line is upper cabinets above the sink box, and the 2 lowers, all dimensioned. There's this microwave cabinet out in the middle of nowhere. I didn't want to go, I couldn't, it had to be this deep to get this microwave drawer in, which I have a spec on. It's an unbelievable thing, this microwave drawer. It had to be this deep, and I couldn't very well put it against the wall because I would be sticking out in the opening. You'd be smacking into it when you walked in this big wide opening here. So I put it out here, left room for something narrow to go in there. We'll figure it out. And there's a window there too. So, and then there's, because as you can see again, 2 wall elevations, A and B. There's the A elevation, showing the crown, the uppers jogged up above where the sink is, showing the sink box, reefer box, uppers above the sink. Calls out, trash pullouts, recycle pullouts, drawers above. And then there's the other wall with that microwave drawer and the window. There's that scope. Oops. There's that scope, 15 items on that scope. So with that drawing, with that scope, or with those drawings and with those scopes, that can be passed out to contractors. Give them a package, and then you would choose 1 or 2 contractors. Some people like 3 contractors. Never go 4. I always ask who's bidding. I always ask how many and who's bidding. And if there's more than 3, I'm not interested. And if there's people bidding that I don't like and I can't beat because they underbid me every time because there's a variety of reasons why that happens. A lot is because they don't have workers' compensation or liability. They pay the guys under the table. They just all kinds of reasons. I want to know who I'm bidding against because I don't want to waste the time. Because bids take a lot of time. So
Why do you bow out if there's more than 3?
because the guy that made the most mistakes will probably get the job. And I don't want that guy to be me. It's just not fair. It's like, I'm not willing to get into bidding with 4 other guys. I'm willing to do it with 2 other guys, but 3 other guys, I just draw the line. And then anything beyond that. So it's reasonable. If you're gonna go to the competitive bid, pick 3 people to bid it. I prefer 2. I'll go with 3, but 4 of them out. Just my personal feeling about it. It takes, like, to really bid a job, it takes a long time. Like, I figure the jobs from 100,000 and up cost me about $1,000 to bid. Cost me out of my pocket $1,000 to bid. The amount of time I gotta go into put a secretary into writing the whole thing up, the amount of time I have to do it, it's at least $1,000. The amount of time I put into a walkthrough, the amount of subs I have to hound to get their numbers. So I don't take them lightly. They cost a lot of money and time, and I want to feel like I have a good chance of getting them. Now, here's some of the picks of that job done. So that
What's your win rate on bids?
too much paper. Way too much paper. Too much paper in my whole life. It's just too damn much paper. Can't even find what I'm looking for. Can I? No. That? Does it look like that? Yeah, it actually does, isn't it? In every detail, that I drew from ideas in my head based on what the owner wanted, based on the configuration of the room, based on what I know about cabinetry, went into my drawing, became that in the real world. Now, there's something about doing that. Having something leap from your mind onto a sheet of paper, and then eventually it becomes something in the real world that people can open and shut doors, put things in cabinets, hit a switch and the garbage disposal comes on, turn on water, all that stuff. So that's what that kitchen looks like. That wall of that kitchen looks like. Another one. Another angle. There's that upstairs, the bathroom, that wall of storage that could have been full height, full depth, but wasn't. Abby picked the. There's that microwave cabinet, right? It's really cool. So you can buy a microwave for a couple $100. They're not very expensive, and there's a bajillion of them and a bajillion sizes. These microwave drawers are $1,200. This one was probably 13 and change with tax, but they're pretty cool, and they look like that close. And that thing on top, this thing here, actually goes flat, but it pulls out, and that's where you read things out. You can't read it too well because typically, like a lot of people do, they don't realize that there's protective coating on stuff. I can't tell you how many times I've been to places and the protective coating is still on. I pull it off, weeks later, like I did to this microwave yesterday. I pulled off this protective coating, so it would have looked a bit better if I'd taken a picture then. And then this is what it looks like. What was that? That's it, open. So you just push this button and it comes out all the way. You put whatever you're microwaving in the drawer, you push a button, it closes, then you however long you want to microwave it. And when it's done, I don't know if it just automatically opens a drawer for you. I didn't get that far. I didn't actually microwave anything in it. But I thought it came out really good. I like the Carrera marble a lot. Not super wild about the colors. I like the white though. I think, to tell the truth, I cannot stand the gnomes. But there's no accounting for taste, and I cannot stand the knob placement either. No, I think you see that line there, right there, the line that if you were to continue the bottom style across, I like that to pick up the bottom or the center, depending on the size of the door. If it's a tall door, I like to pick up the bottom edge of that round pull on that line. This is just way too down there for me. I don't particularly like it, but I wasn't involved in the placement. That was the owner and the light construction that did it, which has, you know, basically, other than my name, has no affiliation in me anymore. Cabinetry came out good. I was very happy with how the cabinets came out. And we're changing out all the hardware, 47 pieces of hardware in that building. One of these days when I get somebody off their duffs to actually give me a bid on it. All right, come back at 5 after. We're having a break right now. So you guys take a break until 5 after 8. Okay, see you back here on Zoom at 5 after 8. All right, good. Video.
5 after 8 or 5 after 7?
I'm recording. Okay, recording. Come on back, Zach, Adair, Eric, Brandon. I know Michael's back. Everybody else, come on in. Come on in. Come on. We got a good break. We're in the home stretch, man. Already. We haven't even talked about it. We haven't even cracked the damn book. So I'm gonna crack the book to Unit 6. I'm sorry, Section 2, Unit 6. We're gonna talk about fractions. We're big on fractions. Construction. Big on fractions. So I'm gonna share my screen with y'all again, and we're gonna fire this baby up. We're gonna turn the lights off again, please. Okay. Very much. Thanks, Matthias. Basic principles of fractions. I meant to release that for you guys, to publish it to see if it would come up, but wow. I don't know why this computer just seems smaller. Is that readable? Look, it's sort of readable. Barely though, really. Oh. That's okay. I'll do most of the reading. So you're supposed to have this book anyway. Okay, so we're going to start talking about fractions, and we're going to talk initially today, right now, about the basic principles of. So the objectives after this unit that we intend to achieve would be to identify the parts of a fraction, recognize the proper and the difference in the and what they are, proper and improper fractions, create equivalent fractions, reduce fractions to their lowest terms using prime factors, and I think that means reducing fractions that are lowest common denominators. And we're going to convert mixed numbers and improper fractions and find the lowest common denominator. Okay, so I'm going to go back down, and fractions are used every day by carpenters. I don't know why. I got to figure out a way to get this full page. That's print. That goes the page on. It just doesn't seem to be any way to get this dang thing to be full page. Okay, so I'm not going to spend too much time on that. They're used every day by carpenters when reading a tape measure. 5 1/4 inches when expressing time, 1.5 hours. The volume of concrete, 8 1/3 cubic yards. How many squares of shingles are needed to cover the area of a gable roof? 17 2/3 squares. Fractions are used to represent a part of a whole unit. It's important for a carpenter to understand the basic principles of fractions before beginning to measure, add, subtract, multiply, or divide them, parts of a fraction. Fractions are made up of two numbers separated by a fraction bar. The bar can be horizontal or slanted, has the same meaning as the divided into sign. So that divided into sign, the line with two dots above it, that's the divided into. 2 divided into 4 equals. You'd have that sign after it. So fractions, it's the same thing. So when fractions can be a horizontal line or a diagonal line, means the same thing, but they both mean, in that case of the 3/4, it both means to convert them to the part of a 1 that it is, or the decimal part of a 1. You just divide the bottom number into the top, and then it's converted. So for instance, 4 into 3 would be 4 into 300, 3.00, and it would be 0.75. That's the decimal. Decimal equivalent of 3/4 is 0.75. The ruler below reads 9/16 of an inch. The whole inch is divided into 16 equal parts. The total division number becomes the denominator. That's the one at the bottom in the fraction, while the 9 highlighted parts become the numerator part on top. To determine the fractional value of the highlighted parts shown, start by determining the number of parts in the whole. Okay, so what do we got? 3 times 6 is 18, and it looks like that's 5, so 5/18, right? Yeah. Right, you see that? That's fractional value, 5/18. So there's proper and there's improper fractions. Now, that doesn't mean, that some fractions are proper and prim and can go anywhere. And some parts are slutty and improper. It's not what it means. Here's what it means. A proper fraction is one in which the numerator is less than the denominator. That's really all you need to know. And the total value is less than 1. So to be a proper fraction, the total value has got to be less than 1. And the denominator has got to be smaller than the numerator has got to be smaller than the denominator. So the one on top has got to be smaller than the one on the bottom to be a proper fraction. An improper fraction is one where the numerator is greater than the denominator and their value is greater than 1. So here's some examples, like 12/5, 17/4, 47/8, 9/2. These are all improper fractions. And then we'll find out how to do this, because when you wind up with a quotient of an improper fraction, which you will a lot when you're adding, subtracting, multiplying, and dividing fractions, you will wind up with an improper fraction. Then you want to convert it to a proper fraction. A whole number, an improper fraction, and I'm sure we'll get to that any second. So here's a math tip. A fraction having the same numerator and the same denominator is the equivalent of 1, right? So 20/20 is 1. 89/89. That's pretty easy. An equivalent fraction are fractions that have the same value, but with different numerators and denominators. Fractions are used to show the relationship of a part to a whole. The same relationship can be expressed in multiple ways. For instance, so this is called a equivalent. Yeah, so that's kind of obvious. Equivalent fraction. So 3/4 and 6/8 are the equivalent because to get to the meat of fractions, you usually want to reduce your fraction to its lowest common denominator. So whatever number goes into the top number, if that same number can go into the bottom number, then you can use it to reduce your fraction. So 6/8 you will almost never see, because 2 goes into 6 3 times, 2 goes into 8 4 times. So 6/8 is actually 3/4. So you would never see 6/8. It would always, if you were adding eighths, like 3/8 and 2/8 and 1/8, and came up with 6/8, you would change that to 3/4. Just like, 2/4, right, is 1/2, because 2 goes into 2, 1, and it goes into 4 twice, so it's 1, 2. If it can be divided by something, then you need to reduce it. So like, for instance, like 14/16. What would that be reduced to? What would that become? 14/16.
7/8.
Exactly. Again, 2 goes into 14 7 times, 2 goes into 8. So if anything will go into those numbers, and it doesn't have to be twos, like for instance, what about 3/15? What would that be?
1/5.
1/5. It would be 1/5, right? 3 goes into 3 once, 3 goes into 15. 1/5. So fractions can be changed to produce an equivalent fraction in higher terms. This is achieved by multiplication of fractions. We'll be discussing more detail in Unit 9. To produce a fraction expressed in higher terms, the original fraction multiplied to fraction. I'm not going to read that. So reducing fractions to their lowest terms. This is what we just talked about. The fraction is considered to be in its lowest terms when it has the lowest possible numerator and denominator. So fractions 1/3, 2/5, 7/13 are in their lowest terms. The fractions 6/27, 8/30, 4/10 are not in their lowest terms. So who can tell me what is the lowest fraction that 6/27 is? What does that translate to? Yeah.
2/9.
Yeah, it would be two ninths, right? 2 ninths. What about 8/30? What is that? What's that? What is that lowest term fraction? 8/30. So again,
4/15.
exactly. Because it's not going to get any lower than that. So nothing goes into 4 that will go into 15 equally. What if it was 4/16? Is that the lowest one?
No,
What's 4/16?
1/4.
1/4. Exactly. Okay, when fractions are not in their lowest terms, reducing is used to convert the fraction to its lowest term. This involves finding numbers that divide evenly into the numerator. Now, evenly is important because you can divide any number into any number and have it carry out to a decimal place or have a remainder. But we don't use remainders, so I don't even know why they even tell us about remainders anymore. But since reducing is used to convert the fractions to the lowest terms, this involves finding numbers that divide evenly in the numerator and the denominator. Continue breaking down the numerator and denominator into numbers they can easily divide it into until they're only prime numbers. Now, they've got to be the same number. So just because you can divide a number into the top number and another number into the bottom number, that's not good enough. It has to be the same number as to divide into the top number equally and divide into the bottom number equally. So a prime number is a number that cannot be divided evenly by only one and itself. I'm sorry, a prime number is a number that can be divided evenly by only one and itself. So you can divide any number by 1. Any number. That's not a problem. And then prime numbers by itself. So 2, 3, 5, and 7 are divisible by themselves. Nothing goes into them evenly. Not true of 8, not true of 9, not true of 10. What about 11? Yeah, prime number, exactly. Not true of 12. What about 13?
Prime.
Right. What about 14?
Composite.
15, not prime. 16, not prime. 17? So it sounds like you all got that. That's good. Determining all of the prime numbers that a larger number can be divided into gives you a list of that number's prime factors. Prime factors, when multiplied together, will give you the original larger number. I'm not sure I understand this, so let's see if I can help myself understand it. To determine the prime factors, of 24, start with the lowest prime number that will divide evenly. In this case, it's 2 over 1, besides 1. So 2 will go into 24 12 times. 12 is not a prime number, so we can divide that by 2, right? That comes in 6. 6 is not a prime number, so we can divide that by 2. We get to 3. 3 is a prime number. So the prime factors of 24 are 2 times 2 times 2 times 3. So 2 times 2 is 4, times 2 is 8, times 3 is 24. That makes sense. I'm not sure how you'll ever use it, but least now we all know it. When using prime factors to reduce a fraction, determine the prime factors of both the numerator and the denominator. Write the fraction with the prime factors and cross out the factors that the numerator has in common. Denominator. Okay, let's just go simple on that one. To reduce 36/98 to its lowest terms, start by determining the prime factors of the numerator. The numerator is what? The one on top, right? So 36 divides by 2 and it equals 18. 18 divides by 2 and that equals 9. 9 divides by 3 and that equals 3. So I don't know why we didn't just go right into 12. But so the prime factors of 36 are 2 times 2 times 3 times 3. Okay. Determine the prime factors of the denominator, 98. 98 divided by 2 is 49. 49 divided by 7 is 7. Now we're down to the prime factors for 98 for 2 times 7 times 7. Okay. Rewrite the fraction with the prime factors. Cross out the common factors that both the numbers can be divided by. The remaining prime factors will show the reduced fraction in its lowest term. So we take 36 and do its prime factors, 2 times 2 times 2 times 3 times 3. And then we do 98 below the denominator. And we go its prime factors, 2 times 7 times 7 equals 49. We, what are we supposed to be doing? So just cross out the common factors that can be divided. I don't get it. Do you guys get that?
Yeah, you were trying to find the prime factors for the,
Well, I mean, the math is relatively easy. I'm just not understanding exactly what they're saying about common factors. And here's the thing. When performing math calculations, it's sometimes necessary to convert a fraction into higher terms if common denominators are necessary. Okay, after calculations are complete, final answers should always be reduced to the lowest terms. That's a good tip. So final answers, you always reduce the lowest common terms. But the things like prime factors, hopefully you understand what we've been talking about. But if you don't understand stuff like that, you're not going to be using prime factors on anything. Nobody's going to ask you to reduce a number to its prime factors. Not going to happen. So I'm not all that concerned about it. Mixed numbers. Mixed numbers consist of a whole number combined with a fraction. It's much simpler to visualize the value of a number as a mixed number rather than an improper fraction. For instance, 3 3/4 could also be written as 15 quarters, right? But it's much easier to understand at 3 3/4. And you might be adding a bunch of fractions, and 4 might be your lowest common denominator. So you're adding quarters, and you might come up with an answer that's 15 quarters or 27 quarters or something like that. Some well above 4 quarters. But that's not the answer you want to give yourself or your guys, or that you want to give somebody to cut that. You want to change that into something like 3 3/4, right? That you can see on a tape. If you're using your tape for 15 quarters, it's not going to work very well for you counting it. There's 1, 4, 2, 4, right? 3, right there at 3/4. When performing math calculations, it's necessary to convert mixed numbers into an improper fraction. It can be simplified by dividing the numerator by the denominator to produce either a mixed number or a whole number. Final answers should always be converted back to a mixed number to express them in the proper form. If the mixed number is above a denominator, if the mixed number above is a denominate number, such as 3 3/4 cubic yards, that's denominates something, it would not be proper to express it as 5/4 cubic yards. Nobody would know what the hell you're talking about. You'd need to express, I'm sorry, I said 5, but I meant 15. You wouldn't say 15 quarters, you would say 3 3/4 cubic yards. Remember, the fraction bar has the same meaning as the division sign. So 20/4 basically means 20 divided by 4, which is 5. Any whole number can also be written as a fraction by placing it over a denominator of 1. I don't know how you'll ever need that, but okay. What's 6/1? It's 6. A mixed number results when there's a remainder left over from the division. The mixed number consists of the whole number that was divided, and the remainder becomes the new numerator over the original denominator. In other words, 47 over 12. That means 12 into 47. Well, 12 goes into 47 3 times, because 3 times 12 is 36, and that leaves a remainder of 11. So you're going to wind up with 3 and 11/12, which is exactly what it shows right there, right? And this shows 47 divided by 12 equals 3, and then that R is remainder. And this is where actually a remainder would work, and we're using fractions. So that, because that remainder, you wouldn't turn it into decimal because we're working in fractions. So it would be part of the denominator, which is the bottom number. Numerator on top, denominator on the bottom. Converting mixed numbers to improper fractions. So when multiplying and dividing fractions, mixed numbers must first be converted to improper fractions. They don't actually have to be, but it does make it relatively easy for purposes of argument and for what we're doing right now. That's what we're going to do. So example, 3 steps are used in the following example to change the mixed number 8 3/8 to an improper fraction. So, well, 8 times 8 is 64, plus 3 is 67. It's 67 over 8. And that goes for anything. So let's say it's 6 3/4. How do we change that into an improper fraction? What is 6 3/4 as an improper fraction? It's 21/4, right? Isn't that right? Wait, 6 3/4, yeah, it's 21/4. Because 6 3/4, I take it back, it's 24 plus 3 is 27/4. 27/4. So just in my head, 6 3/4, I want to get an improper fraction out of it. So 6/4 is 6 times 4, that's 24. And then add 3/4, 3 is 27/4. And if we want to change that back, we take the 4 into 27, which goes 6 times, which is a remainder of 3/4, 6 3/4. Okay, so finding the lowest common denominator. This is where it starts. This is where we get into this. It's relatively simple, but these are the things you've got to remember. When we start adding and subtracting fractions, we need to reduce to the lowest common denominator. And then it gets relatively easy because it's pretty tough to add 3/8 and 1/16. They're not the same. They're not the same. They're denominants. Well, they're not denominant numbers, but they're not the same fraction. They don't have the same denominator, so you can't really add them. You have to reduce them to the lowest common denominator. And here's examples, right? The fractions below cannot be added in their present state because the denominators are not common. So you can't add 3/8, 5/6, and 7/12. You just can't do it. But in that form, so we just got to make them all to the lowest common denominator. So the bigger the number on the bottom, the smaller the denominator, smaller the fraction, right? So a 2 on the bottom is in halves. Can only be 1/2. 2 halves, 2 2s is 1. So 1/2 is 50% is 1/2, right? 16ths and 32nds are way smaller. So the bigger the number on the bottom, the smaller the fraction. So we need to go in any sum of numbers, starting out with adding fractions that have different denominators. We just pick the lowest denominator. In this case, it's 12. It's 12. So can we turn those into 12s? No, we can't turn those into 12s. It's actually, well, let's see. When the denominators are not common, the multiples of each denominator are listed until the lowest common denominator is determined. So 8 and 3 is 24. 6, 4, 24. So yeah, so that makes sense. So 8. So if we can't use 12. 12 is not the lowest common denominator. Even though 6 goes into 12, 8 doesn't go into 12. So we need something to convert these guys to that all the denominators, the bottom numbers, go into. So 12, let's just go, the next thing that 12 goes into is 24, right? 2 12s is 24. So let's see, that might be it. 6 goes into 24 and 8 goes into 24. So yes, it turns out 24 is our lowest common denominator. So now we just need to translate or change these fractions into 24ths. So simply put, to turn 3/8 into 24ths, we just have to take 8 into 24 goes 3 times, and then 3 times the numerator, which is 3 times 3 is 9. So 3/8 is 9 24ths. If you want to prove that, 3 into 9 goes 3, 3 into goes 24 goes 8. So you turn it back into 3/8, right? You just reverse it to prove it. So 5 6, 6 goes into 24 how many times? 4 times. 4 times the numerator, 5 is 20. It's 20 24ths. 12 goes into 24 how many times? 2 times the numerator, 7 is 14. So it's 14 24ths. So you're going to be adding wait, did that finish it?
Just doesn't show the answer.
Okay, it does, doesn't it? Yeah. So it'd be 9 24ths, 1 24 is 13, 2 is 15, 20. What the hell is the answer? Okay, 9 24ths, 5 6 20. Yeah, they're just not showing you the answer. So it'd be 9. I don't know why they don't do that. 9 and 20 is 29 plus 14 is 43. So 43 24ths would be 24 with 19 left over. That's 19 24ths, and that would be it. And I'm really surprised they don't show the answer. They don't, though, do they? And nowhere. Huh. Keep thinking it's pages. All right, fine.
Maybe because they're not showing how to.
They don't care about the adding, they just want us to reduce the lowest common denominator. I got it. That's exactly right. So measuring with fractions. In the construction trades, fractions are as common as nails, screws, and lumber. I couldn't agree more. Imagine tape measures that only measure to the nearest inch. How could anything ever be measured, cut, or assembled with any degree of accuracy? If the board below were measured with a simple inch rule, there would be no way to accurately convey that measurement to another worker without fractions on the rule. Skilled craftsmen are known by their quality work. Fractions provide the degree of precision necessary to achieve accurate measurements and calculations within our trade. Oh, so we're at the review already. All right, let's just whip through some of these. So 1/8 equals how many 30 seconds?
4.
Exactly. Now, if anybody's not getting this, you gotta hold up your hand and we'll explain you. You should get this. So 3/4 is how many 64ths?
48.
How many?
48.
Excellent. And that's because 4 goes into 64 16 times, and 16 times 3 is 48. What 5/12, how many 90 seconds is that?
40.
Exactly. 24 27 is how many ninths?
8.
7 3 3. That's exactly right. 8/96 is how many 12ths? Exactly. And okay, 4/14 is how many 168ths? I think it goes 12 times. I think it's 48. I'm sure it is. 12 times 14. Yeah, it's 168. Okay.
48, is it?
Yeah, it's one. Where was that? Right there. So 14 goes into 168 12 times, right?
Mhm.
Yeah, and then 12 times 4 is 48. So 48 168. And then let's reduce these fractions to their lowest common. What's to their lowest term? What's 5 45ths? 1/9. What's 4 32nds?
1/8.
What's 27 72nds?
3/8.
It would be 3 nights, right? 6 times 9, 72. 3 nights. What's 630? So what is 6/33 reduced to?
That'd be 3 nights or 1/3.
6/33. What does that reduce to?
3/11.
How about 6/33? It doesn't reduce. Doesn't. Oh, I'm sorry, it does. That's.
2
Of
11ths.
course it does. It's 2 11ths. 2 11ths, right? 3 goes into 6 2 times, 3 goes into 33 11 times. I don't know why I didn't see that. 24/64, what does that reduce to?
3/8.
3/8, right? 3/8. 8 goes into 24 3 times, 8 goes to 64 8 times. 3/8. Correct? 55 143rds. What does that reduce to? Got a feeling it's 11ths. I got a feeling it's 5 11ths. Is that right? Or not? Let's see. 11 goes into 55 5 times. 11 goes into, not 11ths. 11 goes into 143. No, it doesn't. Say again?
13 times.
Yeah, it does. 13 times, exactly. So it's 5/13, right? 5/13. And then now, I don't know how to tell you. You just gotta basically, there's no mathematical way of figuring that out other than trial and error, right? That's pretty much it. You gotta just figure. Okay,
That's
what
why-
goes into, well, 55 is pretty obvious. 5 goes into it, but we know 11 goes. We know 5 does not go into 143, right? Everybody knows that? Anything 5 goes into is gonna end in a 5 or a 0, period. If it's 5 times something or 5 divided by, if it's not gonna go equally, if it's not a 5 or a 0. So we know that 5 is not gonna go into 143. So what else goes into 55? 11. 11 times 5. So I'm thinking 11 is gonna go into that. Sure enough, I know that 11 times, 10 times 13 is 130 in my head. 10 times 13, just add a 0 to the end. And then one more 13 would be 11 13s, would be 143. So 5 13ths. How about 88 216ths? What does that get down to? I think 22 doesn't go into it. 22 doesn't go into 216.
8 goes into both of them.
Yeah. 8 does, is that it? So 8 times 11 and then 8 into 216, it'd be 108, be 90, 18, so 11 18ths? Yeah. 11 18ths. And I did that fast because I know my times tables in my head. And I know beyond just 9 times 9. I know that 9 times, I know that 9 times 12 is 108. You should know your 12's timetables because 12 is being inches, being feet, right? 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, 168, 186. And then 132 into 35, 120ths. I think we got the concept, right? We definitely got the concept. Now we want to convert the improper fractions, the following improper fractions, to mixed numbers and reduce to the lowest terms when necessary. Okay, so 14/8. Dylan, what is 14/8? What in converted to a mixed number? Come on. What is it, Dylan? It's a, okay, this is an improper fraction, right? It's because the top number, the numerator is greater than the denominator. So it's improper. We need to turn it into a whole number and we want to turn it into a mixed number, which is a whole number with a fraction. And to do that, we have to divide the lower number into the upper number. So what's 8 into 14? 8 goes into 14 how many times? One time, right? With a remainder. What's the remainder? What's 8 from 14?
4.
Come on, 8 from 14. You can do it. I know you can. What's 14? Subtract 8 from 14. What is it? 6, exactly. Okay, so 8 goes into 14 one time with 6 remaining. So it's 1 and 6/8. Is 6/8 acceptable?
Yeah.
No, we need to reduce it because it's not its lowest. It's not as low as it goes. 6/8 can still be reduced. 2 goes into 6 3 times. 2 goes into 8 4 times, right? So it's 3/4. So the answer is 1 3/4. Do you see that? Dill? Okay. 21/7. Matthias, what is that?
3.
Exactly. 7 goes into 21 3 times with no remainder. All right. John Tapia, 4/29, or 29/4. What is that as a mixed number?
So 4 goes into 29 6 times with the remainder of 3.
No,
Right now,
come on.
sorry, remainder of 5.
Okay, which is greater than 4. So
Which is 6, so
can't go in 6 times. Got to go 7 times.
7 times.
So 4 times 7 is what?
28. So you get the remainder of 1. So it's 7 1/4.
Exactly. Everybody got that? Okay. I'm sorry, tell me your name.
Matthew.
Matthew. I'm gonna get this, Matthew. I'm gonna get this. Matthew, do 24/5. What is that? What's the, what, reduce that to a mixed number, please.
It goes in 4 times, with the remainder of 4. Would it be 5 over?
It'd be 4 4/5. You did the math right. So 5 into 24 goes in 4 times because it can't go into 24 5 times because 5 times 5 is 25. So you got to go to the next one. So 5 times 4, so that's 20. That leaves 4 over 5, and that can't be reduced. So it's 1 4/5. 11/39, Jacob.
11/39.
I'm sorry, 139/11. What does that reduce to?
Let's see, 11 can go to 132 12 times, and that leaves a remainder of 7, so 12 and 7/11.
Very good. Excellent. Everybody see that? See it? It's a relatively simple process. The math isn't very complex. It's smaller numbers. You just got to know what to do with what. So let's convert the following mixed numbers to improper fractions. This is going to be relatively easy because you're going to take the denominator on the bottom. You're going to do it times the whole number, and then you're going to add the numerator. So I'll do this one. 8 times 1 is 8, plus 5 is 13. It's 13/8. You want to prove it? 8 goes into 13 one time, 8 with 5 left over. 5/8, 1 and 5/8. 5 1/4. Ben, what's 5 1/4 as an improper fraction?
21/4.
Exactly. Lewis, Mr. Daniels, the next one, question 33.
7 by 16.
Yep, is what? 70 plus 42 is 112.
Plus 3.
So 115 16s, right? So who we got there? Brandon, can you hear me? Brandon?
Yeah.
Maybe your volume is down. Your volume down.
Brandon, can you hear me?
Yeah.
Brandon, could you please do 34 for us? Change that into an improper fraction.
Let me try.
Okay, let's do it together.
Yeah.
So to change 2 and 2/9 to an improper fraction, you need to take the bottom number, the denominator, 9, and do it times the whole number. So 9 times 2 is what?
18,
Okay, and then add the 2. 18 and 2 is what?
20.
20/9, 29. That's the answer.
Okay.
Michael Silva, do please change 3 6/8 to an improper fraction?
That would be 30/8.
Exactly right. Thank you very much. Okay. Then let's finish up with Zach. Okay. Eric, please, Eric, tell us, and 36, answer 36. So we need you to determine the lowest common denominator for the following pairs of fractions. So 3/8 and 5/12. What's the lowest common denominator?
Okay.
Okay, so what you need to find is what will 12 go into and what will 8 go into?
4, maybe?
No, 4 can be divided into 8 and 4 can be divided into 12, but you can't divide 12 into them. So what does 12 go into that 8 also goes into? So 1 times 12 is 12. 1 times 12 is 12, right? What's 2 times 12?
24.
Okay, does 8 go into 24?
Yes.
Then that's your lowest common denominator. Got it? Okay.
Got it.
All right. Now, Zach, you there?
Yeah, I am.
Do, where are we? Do 37, please.
60.
Very good. And can you explain that, please?
Yeah, I just multiplied the two of them and saw if it could go, if I could simplify it.
What a putz. Just kidding. That's good though. I mean, it's a way to do it, right? But basically in my head, I'm going, okay, so 15 times 2 is 30. 4 doesn't go into that. 15 times 3 is 45. 4 doesn't go into that. 15 times 4 is 60. 4 does go into that. So who else we got? Zach. Adair, can you hear me? Adair? Adair, are you there? Hey, Adair. Well, if I didn't know better, I'd think you weren't paying attention, Adair. I'm gonna give you a demerit. Okay, so number 38. We're getting down to the wire. Austin, what's the lowest common denominator?
Between 12 and 5.
Yeah.
60,
Exactly.
Yeah.
60. Exactly. Because you basically got to take that 12, start multiplying it times 2, times 3, times 4, coming up with a 0 or a 5. Because we all know that 5, it goes into anything equally, has got to have a 0 on the end or a 5 on the end, or it doesn't. We're talking about whole numbers, equal numbers now. So who else we got here? We got, tell me your name again.
Jose.
God damn it, Jose, I'm so sorry. Pardon me for swearing too. It's getting late. Jose, can you do 39 for us, please? Give us the lowest common denominator of 24/8 and 2 9ths. And you could use the same trick that Zach used. It's a good trick. It's an excellent trick.
What trick was that?
That was a trick where you multiplied 1 times the other. What's 8 times 9?
18?
No, 8 times 9.
Oh.
This would be good to study your times tables. So the 9s tables, right?
Yeah, I'll just process it. So it takes long.
Do you know? You got it?
Yeah. Ready? Are you multiplying them?
You can do that. That's a way to do it. If you, that's a way to do it. And that would be the answer. If you were able to multiply both denominators, that would give you the answer. What would that be? What's 8 times 9? Exactly. 72. 8 goes into 72 equally, goes 9 times. and 9 goes into 72 equally, goes 8 times, whole numbers. But 8 does not go into anything that 9 goes into, and any number before that until 72. So that's the lowest common denominator. So you would reduce that to 70 seconds to be able to add it. So, if you were going to do 24 8s into 70 seconds, you do 8 into 72 goes 9 times 24 that way. But we're just coming up with the lowest common denominator. So we want D'Angelo to do 40 for us, please. What's the lowest common denominator?
For 30 and 28.
For 7/3 and 3/28. I'm sorry.
30 and 28.
You're saying 48 is the lowest common? No, it can't possibly be. So what's the lowest common denominator for 3/28 and 7/3? So what does 3 go into that 28 goes into? Let's just start simple. 3 does not go into 28, right? 3 goes into 27 9 times. It doesn't go into 28. So 28 twice. Let's go to the next one. 2 times 28 is 56. Does 3 go into that? It doesn't. Let's do another 28. That would be 60 plus 24. That'd be 84. Does 3 go into 84? It does. It goes 18 times. 28 times. 28 times. It goes 28 times. Yeah. 3 goes 28 times into 84. So you have to find out what they'll both go into, and then that's your lowest common denominator, 84. Now you're going to change those fractions into 84ths. Now, I know some of you are having trouble with this, but the more we do it, the more you're going to get it. And what's going to really help you is to try to work this stuff in your head and do your times tables. Go to that part of the book that has the times tables and just start writing them out. Start doing them. Start thinking about it. Drive down the street and do your 4s timetables. 4, 16, 20, 25, right? Oh, I'm sorry. Which is what? 4, 8, 12, 16, 20, 24, 28, 32, 36, right? Just count by 4s, count by 5s, count by 6s. 6, 12, 18, 24, 30. And the more you do that, the more you get your mind thinking of that, so that you really won't have to think of it. It'll just be there. So that when I see 9 times 9 anywhere, when I hear it, when I see it, I know it's 81. I don't have to think about it, because I've just, over the years, I've used those times tables so much, which most of you should be doing, but some of you haven't been, because you probably relied on your calculators for so long that you've forgotten your times tables. So just try to get your times tables, and it will help you a lot. I told you I'd have you out of here after 50 minutes, and I'm going to do it. So before you go, don't go yet. I want to just make a couple of announcements. Lights, please. Thank you. Yes.
I just had a curiosity. When we're calling one of the students on Zoom,
Yes.
did you let's try calling him Adair and see if he responds.
Oh, Adair.
I don't know if
Wasn't that what I said?
The volume is down, but I don't know if it sounds like.
Adair. Adair.
I mean, he's muted too.
Pardon me?
He can unmute himself. Sure.
Adair. You're
Can you
there.
hear me?
Oh yeah, good.
Sure.
I wondered if you weren't there because I was calling you a while back.
Yeah, I was having trouble with my headset. It's like,
Oh shoot. Well, I'm glad you let me know.
no, yeah, sorry.
Because I was going to give you demerit, but now I take it back.
The answer was 60.
You're back in my good graces. All right, you're good. So this is going slower than I anticipated, but I don't care at all. We'll go as slow or as fast as we can. And we're going to cover this stuff, and we're going to cover it until I feel like, for the most part, you guys are getting it. And then, yes.
What's the hardest math we're gonna learn? Or what's the
Probably the hardest math will be multiplying and dividing fractions. That'll be the hardest math. Well, now I take it back. We'll get into square root and squaring numbers in the Pythagorean theorem. It'll be the only piece of algebra and geometry we get into. We might get into some radius stuff. We'll get into cubic measurement, things like that. But that's about as complex as we're going to get. Fractions will be the most complex, and turning them into decimals, things like that. And this stuff, and reversing fractions and turning stuff over to add, subtract, and canceling stuff out, that gets a little complex, but it is back to basic math. And it's all stuff that your phones, with the calculators that you have on your phones, can do without you basically thinking about a whole heck of a lot. I mean, you got to know what the numbers are, and you got to know what you want to do with the numbers to tell your calculator, because your calculator is a dumb instrument. It doesn't know anything. You have to tell it what to do, and then it will give you answers once you give it the information. But I'm hoping that we can all come together on this, be on the same page where we can all do this without our calculators. And then it'll just make the calculators work even that much better and that much faster and all that. So you guys are a great class. Remember, let me know if, try to make it here, please. If you're going to be on Zoom, just let me know, hey, I'm going to be on Zoom. And if Mr. Barbosa, Miguel, I'm pretty sure he had to work late, right? So if something like that comes up and you got to work late, just let me know, hey, I got to work late, but I'm going to do the class. I'm going to do it asynchronously, but you need to tell me that. And then I will mark you here, and I will believe that you're going to do the class. And you can pretty much do that with any class. It just, I mean, besides wanting to teach you fractions, I'm really lax to say teach you, because I'm just presenting information. Whether you learn it or not, that's on you. So I'm going to present information. But there's a lot more to this class than just fractions and whole numbers and stuff like that. There's showing up, there's communication, there's eye contact, there's participation, there's all this stuff that, you know, we're exchanging. It's happening all the time. And, you know, based on who you are and what you bring to the party, that's how your grade's going to look. And it's not going to be how great you do on the tests. That's not going to be how I'm going to grade you. That's going to factor into how you're graded, how you do on the test. And I'm going to test your knowledge, but that's not going to be what your grade's about. It's going to be how I'm grading what's happening right here, right now. And I can tell you right now that you all are doing great. You're all passing. And then some. Okay, so see you next week.
Yeah. Rodney, I asked a question earlier, but I think it was before you turned your volume up.
Turn this up. I gotta hear you. What was that?
I asked you a question earlier, but I think it was before you turned your volume up.
Okay.
So you said that it costs about $1,000 for you to do a bid.
Yeah.
What's your win rate on bids?
Oh, that's a really good question. Zach, you have excellent questions. You know, it depends, but 1 in 4 was about as good as I ever did.
Mm-hmm. So you spend about $4,000 in cost in bids for every
to get one bid. Yeah.
How much?
Now those were now Zach, that's a little bit skewed, because those would be bids of 100,000 and above. I bid plenty of projects from, you know, 1,000 to 10,000, 10,000 to 20 and 30 and 40, and everything in between. Most cabinet jobs, I do 1 in 3. And those, and a cabinet bid wouldn't cost me $1,000. It'd take me that long. Basically, a cabinet bid takes me, by the time I write it up and do it, less than an hour.
So that makes sense. So on those bids above 100,000.